All right, hello everyone, welcome back. So I'd like to introduce another Kiwi to you who is remoting in all the way from Wellington, New Zealand. I think is it 10:30 for you, Chris?
Yep.
But in the future, right?
Yeah, it's tomorrow.
All right, well, from the future, I give you Chris talking about the future or something.
All right. Yeah, so this is about why people should deploy Faucet. And the thing that people ask is, what's the killer app? And this is where I think people get confused, because it's like asking, what was the killer app of Python? I mean, sure, there's sort of things you can point to, but really the important thing here is that SDN isn't about hardware doing something that it couldn't do before. So if we came up with some kind of application that said, use SDN because it'll let you do this, you can pretty much guarantee that any vendor with any sense is going to immediately just offer exactly the same thing without the extra work. So it's obviously not an app in a regular sense. So I've got a couple of kind of concepts that I wanted to go over here. The first one is simplicity. I sort of started out thinking, I could make the great case of why simplicity is important, but it occurred to me that you can just search any famous computer person and the term simplicity and you'll get a quote. So here's Dijkstra. It's pretty obvious that making things simpler is better for everyone. But what we often find, and as Dijkstra himself seems to have found, that when people say they want simple things, they still seem to end up choosing more complicated options over and over and over again. And then again, you've got this kind of confusion about, when is something simple? Dijkstra complaining about, the monstrum of C++, to me, it's still quite a bit simpler than C for most problems. So, I mean, obviously this was a quote from a long time ago, and I can't really judge it on the terms of the time, but it's hard for me to imagine, getting to where we are now had no one decided to use C++ and had instead decided to wait for the more correct, simpler version of it. So, I mean, it's obvious that, simplicity is a good thing, but you actually have to be kind of clear about exactly what it is you're simplifying and why. Like, who is it that is that we are trying to make this simpler for? And what are they trying to do? And then what are we trading off for that? And I think another thing about simplicity is that, when you have a complicated problem, then you have an amount of complexity there that is kind of guaranteed. You want to find the simplest possible solution, but saying that your solution to this problem is complicated doesn't necessarily mean it's a bad solution if it's a complicated problem. So, I mean, simplicity, you need a simple goal, because having a simple goal actually allows you to evaluate whether your simple answer is actually simple and whether it's going to work. So the lucky thing for us is that networks, for the most part, are quite simple. You're not trying to do like any possible thing that anyone might want to do under the sun. You're just trying to get packets from one place on your network and get them to the place that they're trying to get to, right? And for the most part, that just means reading a packet and forwarding it with a little bit of modification along the way. Right, the problem is that it's a network, so you've got lots of devices, and coordinating things is complicated. And obviously, when you bring in SDN, you're adding an additional level of coordination, because you've got now your software and your hardware has to coordinate. But the hope here is that we're greatly reducing the coordination between all of the devices on your network. So, to say each device just has to coordinate with the controller and can ignore the others for the most part, is much easier than each device has to coordinate with every other device on the network. And bear in mind that coordination doesn't just happen between devices, right? You've got to have different protocols running on your device, then those have to coordinate as well. And one of the big appeals of SDN is, like, maybe this is a chance to just turn some of those off, or simplify them in some way. So kind of trying to bring it down to the simplest possible problem here. I think for most network operators, this is really the trade-offs that they are looking at. They want it to be available, they want it to be secure, and they want it to not cost very much and not require too much effort. And I think this kind of worked out a little bit almost too perfectly. So yeah, I mean, we're close. This Faucet product, I think, sounds great, at least. But coming back to the original one, the main thing that we're sort of targeting here is that effort. By reducing that effort, we can increase the availability and security, or maybe not. Maybe we can just stay with the amount of availability and security that we have and just spend less effort on our network. Hopefully you could reduce cost as well, but I don't think that's really the primary motivator here. It's really about convincing whoever is the decision maker here that you can improve your network by reducing that effort factor. But then there's the problem with that, and that is that software doesn't write itself. So at the moment, there's a big upfront effort cost. And so if you're going to support SDN, then it requires a bit of a long-term commitment. And this is a little bit even more complicated than this, because if you're making a long-term commitment to Faucet, then you are essentially saying, we believe that Faucet is going to be around for a long term. And I believe that that's true, but it can be a harder thing to convince other people. And so how do we convince people that Faucet's going to be around for a long time? Well, the key to that is people have to deploy it. The more people deploy it, the more sort of guarantee you have that vendors are going to keep supporting it. And then the more guarantee you have vendors can support it, the more the easier it is to convince people that committing to SDN is worth it. But I would say, even if you're not 100% convinced that Faucet is going to be the SDN controller of the future, and that maybe P4 is going to replace it entirely, if you are committed to that long-term goal of we can use SDN to reduce the effort that it's going to take to run our network, then consider deploying Faucet, because even though this will be additional work for you in the short term, potentially, depending on your use case, the goal here is to build the support behind SDN itself. And the best way to signal your support for SDN is to use it. And if you're going to use it, well, Faucet's a pretty good option, in my opinion. So that's kind of like the high-level philosophical version of this. But I kind of wanted to do something a little bit more hands-on and operational. So I wanted to talk about how having a simple abstraction kind of enables you to do things that aren't very easy if your abstraction is not particularly simple. Right? So you get giant text here, because I think this point is important. Right? Your flow table shows you essentially entirely the forwarding behavior of your device in one go. So it sort of controls it demonstrates to you the meaningful impact of your configuration and the network state all in one table. So you're not having to think about different places where you might have to look for things. It's all just there in one go, and it's not it's not a case of you put the same config on a different box, but now you've got to somehow simulate the network state. It's all there in one go, almost. So there's a few things that are kind of missing, and a few things that are just not really very clear. So yeah, I mean, the big missing thing, I think, in terms of debugging a network is MTU, because it's always MTU, right? And you don't get to see that, which is a shame. So when we start to think about future, we start making the Faucet OpenFlow spec or whatever it is that we're going to do in the future. If we could pull MTU in there, I think that would be amazing. But also other things like when the OpenFlow spec allows you to specify tunnels, and then those tunnels are kind of OpenFlow has no real visibility into them, how they operate, except that they're there. Really, you want that information in the flow table, because it's pretty useful. I'm really not sure what happens to fragments on an OpenFlow network. Like if I say, TCP port 80 goes this way and TCP port 8080 goes that way, and then we see a fragment, I'm not sure at all what happens to those fragments. I probably could have researched that for this talk, but I think it's gets my point across more effectively to have no idea. And then, there's always the question of, is the flow table actually a very close abstraction to what the switch is doing? And in that case, if you get your flow table, you give it to the switch, and then the switch has to jump through an extraordinary number of hoops to make that reflect on the actual behavior of the device. Perhaps, you've got kind of a black box there that it might really not be doing exactly what it's saying. Right, so, and flow tables are pretty intimidating. They don't look particularly user-friendly, but I think they're not actually nearly as bad as they seem. It helps when they're reasonably nicely formatted, and you get better and better formatting from different switches. So if you're a vendor, if you can, everything you can do to make that flow table more readable, I think is a really helpful thing for any operator or coder. Effectively, you just need to show these are the priorities, matches, and actions. And beyond that, if you try to make that any simpler, you're going to lose information, at which point you're reducing the value, right? So I think you've got to accept that the flow table is something you're going to have to familiarize yourself with. Unfortunately, there's a bunch of tricks in there, particularly relating to VLAN VIDs. And if you're not familiar, the VLAN VID in OpenFlow is a 13-bit field, and the leftmost bit, the most significant bit, represents whether the VLAN is present or not. So whenever you see a VLAN VID in a flow table, often, like if it's higher than 4096, it means you just have to subtract 4096, because that's just indicating that the VLAN VID is present. And yeah, but basically, when you want to debug something and you're like, why is my packet not reaching its destination? Just follow through the table. And it's not, I mean, it can be a little bit tedious, but it's got all the information that you need. So Gauge does flow table monitoring, and we sort of display this through Prometheus and Grafana, but when we do that, it's blocked. It's not the full flow table, it's the information that we've cherry-picked that we think is useful for you. But Gauge flow table monitoring can output the text. It's a bit hideous at the moment. I've currently got a commit going through to make it a lot simpler, where it will just receive the message and dump it to a JSON file. In writing this talk, I realized that there's a bit of a catch there because it's a multi-part message that you receive from the switch. So because the flow table can be large, you can receive it in multiple TCP messages, and I'm not 100% certain that those will all get dumped into one file. If they get dumped into point is, it's not 100% trivial, but it's fairly straightforward. But the nice thing about Gauge is that obviously it can bring the flow table data from your whole network back into one spot. And you get this JSON structure, and you can do things with that. So obviously in JSON format is not particularly easy to read, but on Monday morning, I sort of threw together a little script to tidy up the flow table into a readable format. And this is the sort of first pass at that. I think the big next thing to do is to rename the tables from table 0 to the actual function of the table from the pipeline. So that means I have to add in reading configuration, but it's not that big a deal. It'd be pretty straightforward to do. So yeah, this was kind of Monday morning's, well, half of Monday morning's work. Take a JSON flow table, make it easier to read. But also, I thought, well, I might as well take that to the next step. So you're looking at it and you're going, well, I'm sending all these LICP packets, but for some reason they're just not getting forwarded. What's actually happening? So here's a script that just reads in your flow table. You can pass it a definition of a packet. So if a field isn't included in the packet, then it will always fail to match that field. So any match that matches on your IP destination, for instance, this packet will assume it does not hit that. And then it shows you exactly what actions it applies. Obviously, the better step is to show you exactly what flow tables it hits rather than just the actions. So both these tools that I wrote actually use a little piece of code that already exists in the Faucet code base called fake OF table. It's very deep in the test suite, but it's actually got a lot of potential for doing this stuff. It just builds a fake OpenFlow table and can look it up. The OpenFlow table is just a linked list, but it works well enough for what you need it to. So yeah, you query, you look up, you see exactly what's happening to your packet, and now you've got sort of three possible answers, right? It's hitting a rule that shouldn't be there, and then why is that rule there? Or it's not hitting a rule that it ought to be there, and it's not. Or you're an idiot and LACP isn't really supposed to be forwarded. So, but the problem with this is, right, you see this and you say, it's hitting this particular rule, so why is that rule in the flow table? And that's where we come back to sort of simplicity. Right? The simpler the flow table it is, the easier it is for anyone to sort of to understand why a rule is in there. So if you put a rule in there, I mean, you are effectively, in a small way, reducing the debug, the easiness of debugging your device. Obviously, documentation and tooling is going to help a lot. It would be amazing if we could have some way to like annotate every rule that appeared in the flow table, and then you could sort of say, oh, I look up my annotation and it says, yeah, this is an LACP rule because it's LACP and the controller needs to see that. But ultimately, the fewer rules we put into the flow table, the easier it is to debug things. Right, and here's just some sort of other crazy ideas that kind of came across my mind. So you can write a test, right? You can constantly dump your flow table and verify in real time that your network is never going to forward an LACP packet. And also, bear in mind, flow tables aren't actually that big. So it's plausible to sort of run it in reverse and say, what possible packets could ever forward a packet to port 1? Particularly if port 1 has tight access control, you could build this reasonably easily. And so because the flow table isn't quite big, you could actually exhaustively test every rule combination on your hardware. So when you want to do, you want to replace a switch, you just take its current flow table in its exact form, put it on the replacement switch, and then test every possible rule combination to make sure it does what you want. And you could obviously build this automatically. So you just give it a flow table and it builds all the test packets. I can't really see a way that we could ever have better test coverage than that. Right, and then you've obviously got the question of, okay, my flow table says this packet ought to be doing this, but when I put this packet into the switch, something else is happening. Right, first thing you can do is you take the flow table, load it on the Open vSwitch, and does it still happen? Right, this is basically the am I an idiot check. Am I trying to work out why my LACP isn't being ported? Right, and so let's say it passes that one. You then go, well, okay, I've got one device from vendor A. Let's load up another device from vendor A and see, is the behavior consistent between the two? I mean, there's a lot of reasons why the behavior would be inconsistent between the two, even when the flow table is the same, even if it's not, some kind of physical hardware fault. But it is giving you more ability to kind of diagnose and say, right, these two devices from the same manufacturer running the same firmware with the same flow table are behaving differently. It's likely to be a problem with the hardware. If they're behaving exactly the same, and it's not the way they should be behaving, well, then that's a good reason to sort of get in touch with your vendor and say, I think you've got some kind of problem. And the nice thing is that when you give back to them, you can, if you've got a repeatable fault, like it's much obviously going to make things quite a lot easier for them. Yeah, so that was pretty much all the ideas I could sort of come up with in the sort of time I was thinking. But it's really, the point here is that you've got this very simple interface, and by having a simple interface, it's just, there's potential there to be used in an extraordinary number of ways. And this is where I think, the simplicity of SDN really comes into its own. It's not just the flow table, but that's, I think, my personally favorite example. Yeah, you make your network simpler and amazing things can happen. All right, thank you.
Cool, thanks, Chris. Are you happy to take questions from the audience? Sure.
So just going back to the analogy you had at the beginning about complexity and those fun quotes, how would you describe how Faucet fits into the complexity spectrum, akin to programming languages? I have my theories on that, but I want to hear how you view the complexity question.
Like if I wanted to compare Faucet to a programming language?
Yeah.
Well, I'm a fan of Python, and I try to sort of take a lot of the sort of philosophy of that I've tried to apply. The sort of, there is a Pythonic way of doing things. Keep it as as comprehensible as possible. But that's kind of the goal. But I don't really know exactly how well I could really claim that we've achieved that. But yeah, I guess, not really being a languages expert, I'm not as sure where to go that way. But I think, the simplicity is, like, Faucet is not very powerful compared with almost any other controller, right? It's very, it doesn't do a lot, and that's a goal, really. So yeah, I don't know if you can think of a programming language that tries to do as little as possible, then maybe we're in that sort of scope. If you have a thought, then I'd love to hear it.
Yeah, I mean, my thoughts were that roughly I see Faucet right now mostly at the C level, C programming, and some of these other things that we're talking about start to get to more C++-ish. So it's
Right.
really on that verge of the basic design. Is this really simple, straightforward, not a lot of indirection in there, but then the newer constructs are starting to get a little bit above that. So, and open flow tables are definitely machine language assembly.
Yeah, well, I like, machine language and assembly is like, it's something that nobody should ever have to interact with. And I think the flow table it's not that. And I think that's what people think of the flow table, that it's your assembly level. But it's actually something you can interact with and understand pretty well, right? I mean, it's not very nicely presented in general. But to me, it's the equivalent of looking at like a firewall rule, right? And no one ever tries to tell you that a firewall rule is assembly or machine language. I mean, they're quite sophisticated firewall rules, but I don't think it's as hard as people make it out to be. I don't know, like, every person that I know that operates a Faucet SDN network spends a lot of time looking at the flow tables. Yeah, I think they get a bad rap.
Hi, Chris. So just first one, just an observation. In your abstract, you talk about making hardware stupid and inflexible. I agree with the stupid part, but I think it should be flexible. But no, just an opinion. Second part is actually more to the point of working with the flow tables. So you have some tooling. What's the representation of the flow table? Is that an output which is going to be vendor specific? Is there a canonical format? Is there certain tooling which you're going to add into, commit into the Faucet code base that people can play with it and extend it, etc.?
Yeah, so I sort of threw these scripts together on Monday morning. They're pretty hacks at the moment, but they make actually, most of the work has been done by this like OF table little script that we've got hidden away in the test suite. So I am thinking about doing a bit of work to extend that, and then maybe documenting it a bit better. My time for working on Faucet these days is a bit reduced, so it might be a bit of a slow process. But yeah, I hope to kind of publish some beginning tools and maybe some guides about how I made them to sort of help other people who want to have some better tools for the flow table.
Okay. Thank you.
Hi. Long-time listener, first-time caller. It's so if you can't see me, I'm way over on this. Here, I'll come over here so you can see me.
No, that's all right.
Fascinating discussion. And I thought I would throw my 2 cents in. Flow tables to me they're not a language. They're a data structure. And as a data structure, there's a lot that you can do with them, including doing things to make them readable by humans, or to extract their information, or change the presentation layer somehow. And so the thing that you made that actually reduces the flow table to the essential information that a human would want. I find that very intriguing. Right? I like that. I like to see it. But as evidence of, I wouldn't go fixing flow tables. I would fix the tools that you can, where you can show what is in the flow table and make sense of it as a person. And as evidence of this, I will tell the story of someone that I met that they had a data structure problem. Right? They had a table in a database, and they didn't like how the report came out when they generated a report from that table in that database. And so what they did was they exported their whole database, or the whole table, to Excel, and then they swapped the columns that they wanted to appear in a different order, and then they made a new table with the new schema that had the columns swapped, and they stuffed all the data from Excel back into the database, and then the report that they generated came out the right way. And I forget the details, but I said, well, in your select statement, you can do this thing and it'll move the columns around for you at the presentation layer. You didn't have to go change the schema. And apparently I saved them, a couple of hours of work per day, understanding that the data structure and the presentation of it are in fact decoupled. And so, to the comment about whether Faucet is like C, I would argue that Faucet is not it's not a programming language either. There's a thing underneath it that's written in Python, but itself, it's as a structured configuration that causes flow programming, that causes database entries to be populated, right? Table entries get populated. As an expression of the schema that then information from the network causes the tables to be populated according to the schema that Faucet sets up. That's how I think about it. And again, understanding that the presentation layer can be separate from the data structures that actually drive the application to do what it wants to do. But I know that's my 2 cents worth. And now that Dan's not paying attention, I'm going to shove the microphone in his hand and say, "You're next."
Notes what you just said, Stephen. Just a simple question, Chris. What are your thoughts on Open Kilda?
I'm not familiar.
You don't know it? Oh, it's an
It
open
sounds familiar,
source
but I don't know it off the top of my head.
SDN controller that Telstra is using. They wrote it, they're using it. Came out of PACnet, and apparently it's very easy to deploy, and it's in production. They don't have a large community around it, but John Vestal is very excited about it, and it's just across the water.
Oh.
Anybody here have experience with Open Kilda?
The name has sort of crossed my but I'm not familiar. I guess I can't really comment. But yeah, sounds great. I'll take a look.
Okay, that's all. Thanks.
Anyone else got a question for Chris? No? Well, thank you. You can go and return to your day. Thank you for promoting.
Thank you very much.